Breaking news. A new peer-reviewed study at Clark High School during second period lunch has investigated the relationship between the average hours of sleep a student gets and their unweighted GPA. Tonight, me and my coworker will be sharing a bit about this data and having our experts come on the show to give us some more knowledge on this data set.
Today, we welcome statisticians Jaden and Diva to tell us a little bit more about the data. Thank you for coming.
Thank you for having us.
Thank you for having us.
Off the bat, what can you reveal about the data displayed on the screen now?
Well, we can see that there appears to be a weak to moderate positive linear association. This means that even if the data points don't make a perfectly straight line, there is still a somewhat linear relationship between the GPA of these Clark High School students and the amount of sleep they get per school night. There is one unusual feature of this dataset that will be discussed later on. We also found a linear regression line with a y-intercept of around 2.2, meaning someone who gets 0 hours of sleep on average per school night is predicted to have a 2.2 GPA.
After doing some statistical analysis, we used our linear regression model to calculate the residuals and create a residual plot, as shown here. This residual plot helped us see how close the data points were to the predicted regression line and provided other important information regarding the data set.
And is there anything unusual about this data?
I'm glad you asked. Going back to the original scatter plot, we can see that there's actually an influential point right about here, because an individual reported achieving a grand total of 0 hours of sleep on average per night and having a current cumulative grade point average of 0.4. This point increases the strength of the linear association, as this point has a large influence on the line of best fit and uses its high leverage in order to influence the line of best fit.
So what else can you tell us about your study?
As referenced before, there is something called a residual plot. This plots the distance between the real value of each individual data point and their predicted values based on a linear regression model. The residual plot for this dataset is shown right here. This residual plot does not have a clear pattern to it, meaning that a linear model is a good fit for this data.
I've heard that if a residual plot has a pattern, it means that the linear regression line is not a good predictive tool for the dataset. So, it's good that the residual plot showed no pattern. If the regression line had formed a parabola shape, for example, that would have meant that the data was slightly curved.
That's right. It is also important to see that the residual value for this point here is much greater than the rest, which strengthens the argument that it is an influential point. If it were removed, the lines of best fit would likely be higher, as this influential point brings the trend line down towards it.
The R-squared value for this dataset was 0.175, meaning that 17.5% of the change in a student's GPA can be attributed to the variance in the amount of sleep they get per night in hours. This shows the relationship between the two variables.
We really appreciate it, and looking forward to learning more about statistics in the future. This is Period 6 News, signing off.